Hello, everyone, and welcome to Why Inventor and Why Fusion 360. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is Richard Ryder, our applications engineer. By the end of this webinar, you have learned the differences between Inventor and Fusion, allowing you to identify which software better suits your business needs. And that is definitely worth 30 minutes of your time. Throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Richard to revisit a step or ask any question. This is your time, and we want you to make the most of it. And in the upper left-hand corner, you will find links to our YouTube channel, social media, and website. So yeah, make sure to check our YouTube channel. We post all of our webinars there at the end, so you can share with colleagues or rewatch it on your own time. And without further ado, we'll pass it on to Richard.
Hello, everyone. My name is Richard Ryder, and welcome to our MicroCAD Inventor Fusion 360 comparison webinar. Today, we're going to talk about some of the strengths of Autodesk's premier product design applications. So again, my name is Richard Ryder. I am an applications engineer with MicroCAD. A quick background is in manufacturing, covering a wide range of processes such as industrial, automotive, structural steel, machining, CNC operations, as well as sheet metal fabrication, power systems controls, and computer systems diagnostics. And please forgive my southern accent. I have been told that I have a little bit of one, so just bear with me on that. So starting off, I'd like to get into some of the manufacturing workflow environments. So let's first talk for a second about documentation. And this is the detailed manufacturing drawings that pretty much all companies utilize. There is a different direction that modern industry is going. It's called model-based definition, and we're going to touch base on that in just a minute. But everybody is creating drawings for production. So that is one of the considerations that you will take in manufacturing. Also, another consideration is your data management. Revision controls, life cycle management, collaboration within your team are considerations as well. Collaboration and automation is a big factor. Some companies really want to get highly automated with their workflow, and there are certainly tools within both applications to do that. CAM manufacturing, if that is important to your company, both of these products have that offering. We'll be discussing more about that shortly. And then you have your plastic, sheet metal, steel industries that these softwares kind of cater to. Another workflow environment is simulation. And that's where you can actually get into testing with analysis. There are tools within both these programs to do that. Also animation for presentations, if that's important to your company, and rendering, how to make all of your designs look really lifelike. And as I mentioned before, you have model-based definition. So there's kind of two ways that a company can go with getting information out to the production area. You can produce drawings, send it out, or you can use model-based definition. What model-based definition is your design incorporates all of the information that is required to build from. With access to a computer out on the shop floor, workers can access that data directly through the model. So that's what model-based definition is. And industries are growing closer to that more and more as we go. And then we have generative design. That is an up-and-coming technology. This illustration that you see on screen, that was created with generative design. So let's get into Inventor first. We're going to discuss where Inventor excels. First off, let me start off by saying that Inventor is a professional-grade 3D application for product design and engineering. It is Autodesk's flagship modeler. And what it excels at is engineering is one of the areas where Inventor is most useful. It's actually an engineer's tool. It's also great for large assembly modeling. If you have a model or an assembly model that contains hundreds of parts, you're probably going to want to lean towards Inventor. Another advantage of Inventor is iParts, iAssemblies, and iLogic. With these features, you can really go deep into your design and have it automate and update the configuration of your designs at an instant. Data management and collaboration with Vault. This is one of the areas Inventor shines. It has a direct, seamless link to Vault. And if you're not familiar with Vault, Vault is kind of a file storage system. You can have Vault highly automated. It contains product lifecycle management tools, revision controls, just a load of features that usually a large team would need in a storage system. When you put your information in Vault, it is secure. You can assign permissions within Vault. So that could be very big for certain companies. And I just mentioned automation within Vault. Your Vault information can be kind of assigned to your drawing in certain places, with certain triggers that are set by your programmer. Dedicated local file structure. So that is how Inventor typically saves all of its information. It will be saved in your directory within your operating system. Fusion kind of handles that a little differently, and I will get into that when we get onto the Fusion page. But as it's stored in the directory and works with Vault, it can automatically go into Vault, and you can go and check your files out of Vault at any time and work on those, and then check them back in, and that also keeps others from working on that file at the same time, so it avoids conflicts, especially for large team collaborations. So one of the stars of Inventor is the frame generator and the content libraries, well, two of the stars. So the frame generator is certainly useful because you can develop your line work to produce the skeleton of a frame that you would like to use or produce and design, and it will populate all the members for you. So it's extremely efficient when creating a frame. And then the Content Center Libraries has a vast array of fasteners, fittings, structural members, any kind of typical parts that you would normally find in a manufacturing environment will be found within the Content Center Library. Another shining area in Inventor is sheet metal design. I've worked with the sheet metal design portion of Inventor for quite a long time, and it is stellar. I enjoy all the tools and the offerings with Inventor. I would definitely give the edge to Inventor when it comes to sheet metal design. Also, we have mold design within Inventor. Now, this kind of gets split up between the two programs because you have the ability to design the mold in Inventor, and then in Fusion, they have a way to test mold flow. So they kind of, separated those, and you can have access to both of those through the PDM collection, and I'm going to talk about that more shortly. But I thought it kind of odd that they split that up, but it is what it is. Also, you have your BIM exchange. So that's Building Information Modeling. So you can directly communicate with BIM 360 in Inventor, and you do not have that ability with Fusion. And also a couple added bonuses within Inventor is your tube and pipe and cable and harness. So those are integrated within Inventor. And if you create wiring harnesses, or if you work in electrical with power systems controls, it's a perfect match. Electromechanical is very important to industry. So that is a highly capable program that's installed inside Inventor. And I also like to throw in my personal pick for each program. And my personal pick for Inventor is the overall HD graphics. It has a really crisp, clean feel, and I just feel that it's high definition view in this interface with Inventor. So let's move on to Fusion. So Fusion 360 is an integrated design and simulate system for product design. So where Fusion excels is in product design. This will appeal to product design specialists. Another draw to Fusion is the cost. It's quite a bit cheaper than Inventor. It's also a hybrid application. So Autodesk touts that it's a cloud-based software, but there is the ability to save locally on your directory. So it's a hybrid application. So you can save on the cloud or you can save locally. Now, one thing I'd like to mention here is that at this time, there is no direct link to Vault within Fusion. There is a workflow that you can achieve that, but it's a little bit time consuming, and that kind of defeats the seamless purpose of Vault. It can be accomplished, just not that easy. It's platform independent, so it doesn't matter if you're on a Mac or your Windows 10, it will operate on any platform because it is cloud-based. So the star of Fusion 360 is generative design. Inventor does not have that. Rendering. Fusion has an advantage on rendering. It has a deeper tool structure for rendering. It's integrated in Fusion along with several other systems like CAM and your PCB. That's printed circuit board modeling. So you can actually model a circuit board. You give it the inputs and configure it, and it will produce a printed circuit board in your environment for you. Fusion 360 has a robust 3D printing interface. So I would give the advantage to Fusion 360 if you are going to be 3D printing. Fusion also holds the advantage on community resources. So Fusion kind of lends itself to a younger generation. Inventor is more for the engineer, the 9 to 5. You come in, you put your time in, you go home, you don't think about it too much. Fusion is a little bit different. Even though engineers certainly could use Fusion, it appeals to hobbyists, it appeals to smaller companies, it appeals to the younger generation because it's a little bit of a lighter learning curve. And because of that, the hobbyist aspect, people tend to be more involved with the community online. So there's a lot more information. There's blogs concerning Fusion and more videos that can be watched online. So the advantage is definitely with Fusion when it comes to community resources. And then form modeling. Although you have form modeling, that's mesh modeling in both programs, Fusion kind of has the edge on form modeling. So it's good when you want to blend organic and mechanical together, or if you're designing ergonomic features. And the Fusion 360 extensions. So it's a little bit cheaper to buy the base program in the beginning. But if you start specializing in a certain discipline and you want to go further and become more productive and efficient, you can start to explore Fusion extensions. And if you was to outright buy the extension, it kind of negates the cost. But you do have an option of flex tokens. So you have the ability to actually access any of the Fusion extensions using your flex tokens. And that really keeps the price down. So it's good for everyone to know about that, that you don't really have to buy the extension outright. And I am going to talk a little bit more about some of the extensions that are offered. And so my personal pick for Fusion, one of my favorite things is the Fusion 360 Triad. And what it is, it's a little tool that kind of helps you directly manipulate your model. And it seems to be everywhere. And it's a highly functional little tool that just keeps popping up, and you learn to use it and you become very productive with it. So, and Inventor doesn't have that. It does have direct modeling, and it does have a similar triad, but it's not quite as prevalent as it is in Fusion. So I've really come to like that little triad. So here are some of the add-ins that you will find in Inventor. So cable and harness and tube and pipe, like I've mentioned before, they are included. And here are a couple examples illustrated. The automotive industry, any kind of electrical boxes or anything like that is perfect for cable and harness. Here's a good example of tube and pipe. It is good to note that some of the other offerings available to Inventor can only be accessed through the PDM collection, such as your CAM interface, which is CNC programming, and nesting, and Nastran simulator. So you would want to look into the PDM collection if you were interested in taking advantage of those offerings. And here are your Fusion 360 extensions. You have your simulation extension, generative design extension, machining extension, nesting and fab extension. Your product design extension, manage extension, and additive build. So just to talk a little bit more about what each one of these are. So simulation helps you investigate how efficiently your 3D design can be manufactured or how it may perform under real-life conditions before manufacturing. And the Generative Design extension allows you to quickly explore high-performing design iterations to reduce weight, improve product performance, and consolidate parts. Your machining extension offers advanced machining functionality. You gain access to 5-axis machining and add to more 3D axis milling with advanced strategies, toolpath optimization, and process automation. Your nesting and fab extension unlocks advanced capabilities to create optimized and associative multi-sheet layout for sheet metal and non-sheet metal parts. Your product design offers advanced modeling tools, which simplify the product development process and enables an automated approach to creating complex product designs. Your Manage extension helps you with data management. You're able to manage design changes at any stage of production with the click of a button using pre-built workflows. Automation. And your Additive Build 3D printing extension. It helps you automatically orient parts, creates high-quality finishing operations, and generates fully associative support structures. And as you can see, here's an illustration of the advanced generative design. You can see multiple parts have been created with the extension here. And of course, your 5-axis machining, which is able to rotate around all 5 available axes while machining. Some other design considerations to take into account is your platform and data management structure, your document augmentation needs, and if you specialize in a certain discipline or use several disciplines within your company. If you are in engineering versus product design, and of course your budget. You also have to consider if you'll be producing presentations and if those are important to your company. And the GDT annotation, which is geometric dimensioning and tolerancing. If your company takes advantage of this workflow, you'll probably want to lean towards Inventor. And also analysis. If you test a lot of different applications, then that will be a huge consideration for you. Then 3D printing with generative design. Most generatively derived parts are 3D printed. So you'll have to ask yourself, what is my end goal and how am I going to get there? So here's a few examples of what maybe Inventor is not so good at. So one thing to note is Inventor has peaked as to what a professional engineering firm would need. So one of the downsides is you need the collection for a few of the added features, such as CAM and nesting. It has a limited 3D printing ability, although you can do it, it's limited. And I put rendering and ray tracing on here because the ray tracing hasn't been highly developed yet. This is something that's not offered in Fusion 360. The ray tracing in Inventor is in its infancy at this point, and it is getting better as they work on it. But it's just not as good as ray tracing should be. And as concerns to rendering, you do have the ability to render in Inventor, but Fusion holds an advantage. There's no generative design, and there's no PCB creation, and that's printed circuit boards. You don't have any plastic mold flow analysis, which I feel probably should be in the same program. So here illustrated are a few of the examples. The motorcycle has a generatively designed swing arm, and there is an example of a printed circuit board and a GIF that kind of shows rendering and ray tracing. So what Fusion is not so good at, it only has a McMaster-Carr library. You have an access to that, although it is a fairly comprehensive library offered through McMaster-Carr. It's not quite as good as the Content Center. It's not integrated. It's just a link, and you can bring those parts into the model, but I don't feel like it would be called integrated. It's not ideal for large model assembly. The illustration at the top shows that. That is an Inventor illustration. And when you get into, let's just say hundreds of parts, the list grows pretty long in Fusion because it is a multi-body environment. It doesn't have the part structure like Inventor does. Inventor, you're able to create an independent file for each part, and all of those files are contained within your directory, and they can be accessed one at a time by themselves. Within Fusion, it's not quite like that. You have an environment, and you build all of your parts within the one environment and kind of separate it in your browser. All the features found in your timeline in Fusion, they're all together with everything else. So if your assembly model starts getting too big, then it's kind of hard to trace through that timeline and find some of the features that you might need to modify. So also Fusion does not have the frame generator. It does not have logic programming abilities. And there's no electromechanical link. No tube and pipe. And it only has a user certification offering. And I am going to touch base at the end of the webinar on the certifications. You can gain access to professional certifications and user certifications for both programs. So when you're considering which application might be right to you, I would recommend considering why not use both. You could leverage both applications with the product design and manufacturing collection and have the best of both worlds. So now you actually have the ability to communicate with both programs. You have a send to Fusion 360 command within Inventor, and you can also find and access Inventor files through your desktop connector. Note, this only works with Inventor 2022 or newer, and it only works for part files, but you can create multi-body parts in a part file and take an assembly into Fusion. And one reason why you might need to do that is you have your mechanical structure in place, but you want to incorporate some generative design aspects into your model. So you can send your mechanical assembly model into Fusion and have the Fusion AI create that generatively designed figure that you want to implement. Touching on generative design for 1 second. So this is kind of turning into the wave of the future. AI takes over the design process. It's fast. You can let AI do all the work for you. Excuse me. You set the parameters and let the machine do the work while you go grab a cup of coffee. Here's a few examples of what generative design could look like. And I would note personally, from personal experience, that the generative design configuration process is similar to your analysis process. You go in, you set constraints, you tell the computer what surfaces that you're going to use, and you set your loads and everything, and it will take over after that point. It will give you several iterations of your design, and then you can select through which one looks like it will work best for you. Once your generative design is complete, you can actually go in and manipulate the model further. And some of the newer technologies that are being implemented in industry today, generative design, design optimization, simulation and analysis, additive, 3D modeling is additive, molding, CNC, metrology, which is the measurement, composites and fabrication, prototyping, jigs and fixtures, tooling, DED, which is metal additive, 3D printing using metal, and CMMs, coordinate measuring systems, fabrication, and robotics. So Autodesk has offerings to accomplish all of these new features in industry today. Some of the best fits for each program. So Inventor caters to engineers, mechanical, aerospace, auto industry. It's a good fit for construction as well. Sheet metal, weldments, and structural steel. A good interface for robotics and model-based definition. It's great for large-scale industrial engineering firms. And it also excels at rules-based designs, where you configure how the design is supposed to work and write the rules for it, and everything is automated after you set up that configuration. So Fusion 360 caters to product developers. Plastics, if you care about efficiency, then you would go into generative design. Mesh designs concerning ergonomics. 3D printing is strong for Fusion 360. And I had to include the auto industry for Fusion 360 as well. There's a lot of curved surfaces in auto industry, so both of these products work well in the auto industry. It also appeals to hobbyists for the cost, community learning, and the art aspect. Here is a good illustration to indicate how it kind of falls between companies. If you're a smaller company and you're not big on investing in software, then Fusion 360 will appeal to you. If you're a medium company, it could go either way. Large scale company, I would say, yeah, you're probably going to want to use Inventor. You'll have a large team collaboration environment, and you will probably want to utilize Vault. And I'd also like to quickly touch at the end of our webinar here on our Inventor Certified Professional Certification offerings. Autodesk has provided a way to get certified at each program, and it was a little disappointing to me to find out that Autodesk only offered a certified user certificate for Fusion. But one of the advantages is that you'll earn recognition for your expertise and accelerate your career. You'll help make an impact in your organization by utilizing the badges that are assigned to you after you have completed your certification exam. As you can see on the screen, that is my email signature, and you can assign those badges to that signature and link it directly to your certification page. So anybody at any time can click on your badge and see that you are professionally certified. And one other thing that I always like to mention whenever I'm talking to anybody about 3D modeling is this awesome little product right here, the Spacemouse. So this is a little joystick that you use to manipulate your model, and it is amazing. It was a game changer when I started using this. You don't have to keep reaching up and touch the keyboard is one of the huge advantages. And they have a couple levels that you can access. Well, they actually have several, but I only recommend 2 of these. The Spacemouse Wireless, which is called the Puck. It is the cheaper version. Maybe good for beginners. It's about $130, $140. And then you have the Enterprise. So this is a fully programmable device that interfaces perfectly with Inventor. I used mine for a very long time. The muscle memory is built in, and whenever I have to work on a computer that doesn't have this, sometimes I feel a little lost. But I like to make everybody aware of this device, and maybe you could look at it and see if it could help you out. Oops. So with that, I will go ahead and end our webinar for today. Feel free to contact any of our sales team at these numbers, or they're also found on the website.
Thank you, Richard. Thank you, Richard, for the wonderful presentation. And as a reminder to everybody, you can ask a question on the left-hand corner. I see a question coming in, and it is, what are some of the biggest challenges when learning 3D modeling software?
Okay. It helps to have a mechanical mindset. It helps to have some experience in the creation of construction of tangible items. And the ability to problem solve with patience is something that is needed. Sometimes there's a trial and error phase you might have to go through, and the more you commit yourself to the problem solving aspect, the more you'll achieve.
Thank you. And another question. If I don't plan on learning other software, why should I buy the PDM collection?
Oh, great question. If you are dead set firm that you are determined not to learn another software, then don't get it. But the little bit extra that you'll spend to gain access could turn into a game changer in the way of productivity, growth, efficiency, abilities that you might not have known about, and you'll have time to find those out. The PDM collection costs about $3,000, I believe, and a single seat of Inventor, I believe, is $2,300. I think I calculated that one time, and it's about $58 a month difference to gain access to Fusion 360, AutoCAD with specialized tool sets, which includes mechanical, architectural, electrical, raster design, all separate programs that come with the PDM collection. You'll also get 3D Max and Arnold for high-end rendering if that's important to you. And it also offers insight if your company is interested in helping to save the planet. Also, you'll gain access to HSM Works, CAM, and nesting tools with Inventor, and it's only available through the PDM collection.
Great. And another question, this is a good one. Will Inventor and Fusion 360 be combined in the future?
I do not believe it will. I've actually done some digging on this, and they are two separate products, and here's why. The target audiences, they cater to different crowds, and all, even though they're similar packages, they're different in capabilities. They do have their own standalone offerings. You can accomplish the same thing with both programs. You just have to consider which one is going to be more efficient or productive. And also consider the specialties between both programs.
Got it, thank you. And as a reminder for everyone, if you want to learn these topics in detail, you can always take a custom training with Richard or someone else on our team. We also offer group classes online. So be sure to be checking the MicroCAD website for future webinars. And that concluded our webinar today. Thank you so much for attending.